Happy Thanksgiving, everyone, and welcome back to AI Chronicles. I'm Sonam, and today we are going to talk about knowledge graphs and how they fit into the constantly changing world of AI. Joining me is Mark Adams, co founder of TrustCraft AI, a leader in making data and AI work smarter together. Hey, Mark, thanks for being here. How are you doing?
I'm doing well, thank you. Great to be with you. It's
Likewise.
yeah, happy Thanksgiving, everyone.
Yeah, thank you so much. Without further ado, knowledge graph is something I have been trying to explore since I don't know how long. I worked with vector databases, and I was also like building a project, and I was wondering, if GraphRag or building some kind of graph would make sense. So I'd like to start from the basic, and I'd love to know what is a knowledge graph, if you can tell me like in simple terms.
Yeah, sure. So I guess to start with, I guess it's useful to think about the knowledge graph as a store. So it's a store of data of some kind. And there's different kinds of stores in the world, as you know. There's like relational databases which handle table stuff very well. There's key values, which are very simple, store an associated key with a value, and graph stores, which are very good at storing relationships between things. So
Mm-hmm.
that's the first interesting property to talk about when we're talking about knowledge graphs. But I think if you, the phrase knowledge graph probably hints at what you're going to be using it for. Knowledge graphs are really great at starting to deal with complex knowledge, perhaps even human knowledge, where there is a lot of relationships between things. So one of the examples of a use of a knowledge graph might be if we're going to be doing some analysis on fraud data. Fraud data is particularly complex. Financial arrangements of companies, especially a company trying to commit fraud, is going to probably have some very complex affairs. And so knowledge graph is very good at understanding complex human knowledge and the relationships between things that allows that to be mined easily.
Got it. Got it. And I know you mentioned an example, but if somebody new who's getting into this area and want to understand why should one use a knowledge graph, how would you tell them like, okay, yes, with the fraud data, the complexity, it makes sense. But if you were to explain like, okay, take any example which would be relevant more. So how would you go about telling them why they should use a knowledge graph versus like not use them in any application?
Well, I think anybody choosing how to store data, that is always some complex decisions there, but you
Mm,
look for certain clues, don't you? So if you're dealing with lots of tabular data, you probably would think, well, let's start off with an RDBMS and see whether that works. So for a knowledge graph, the clues might be you're dealing with data that has a lot of relationships between things. So
mm,
the relationships go deep. Um, so for example, if we were looking at company data, companies are often related to other companies and related to directors. You kind of, if, to understand a company, you would see a lot of relationships between things, and that's a clue you want to get
mm,
into the knowledge graph space. I think one of the other things that's worth looking at is if the relationships might emerge over time. So
mm,
if you are in the space of discovery, you might not know what relationships are important. And so knowledge graphs can also be very good at adding relationships later because
mm.
there might not need to be any schema change. Some of the graphs are very good at absorbing change very easily.
Right. And so I know knowledge graph is more like I have learned about it since like computer science days. And now I'm wondering like from the traditional usage to the modern ones, how do you think the knowledge graphs have evolved?
Oh, that's a good question. Um, I think I've been tracking the technology for a long while, and when it first came out, I think people thought these are probably these kind of stores are probably aren't great, and I think when they started to emerge, they were slow. People were probably building the wrong stores, so people would often build a graph store using an RDBMS, um, and the type of queries you do are very bad for an RDBMS. So it got the reputation of being clunky, slow, badly supported, um, query languages, impossible to understand, not a lot of information. My friend Daniel's quite interested in knowledge graphs, but
Right.
he still gets in touch the whole time. When he's got questions, he says he can't find the answers out there. So I think the feeling is that it's only fairly recently that it's started to become a really mainstream technology, widely adopted, and so I guess the path to adoption and the path of development of real world algorithms that work well on knowledge graphs seems like it's, I think, relatively recent that we started to see a lot of progress.
Yeah, I think maybe it could be because of the growth in unstructured data and the whole relationship with metadata. That's what my understanding is, that why people are getting into exploring knowledge graphs more and more. Would you agree with that?
Oh, absolutely would. Yeah, so certainly, I think, all of these structured stores we're dealing with, the bulk of human knowledge is still largely unstructured, isn't it? It's
Yeah.
documents and pages on the internet.
Oh, yeah.
Um, we were talking about financial data just now. When companies release their annual reports, there's a bit of
Mhm.
structured data in there and reams of unstructured stuff.
Right.
So I think one of the interesting developments, I guess we'll get onto in a bit later, that is how AI is really unlocking some of that unstructured data and allow you to use a structured store. And so therefore it's not a surprise that when you're dealing with like the sum of human knowledge, some of the knowledge that's getting unlocked, people are now increasingly looking for a knowledge graph as the solution for storing that data.
Yeah, yeah, I totally agree. And, speaking of all these new evolution and the whole fast-paced changes that we keep seeing, I know there have been many terms that have been floating around in this space, for example, graph rag. But I would like you to tell us about RAG for, considering all the tech and non-tech folks who might be listening in.
Sure. Perhaps it's best to start by describing the journey. So I guess AI has been a technology for decades, but actually, to a lot of people, it's a very recent technology as LLMs were launched into the scene. So I guess when those pieces of technology started to appear, you had a model that could answer questions, but the only questions it could answer was based on the knowledge that it had been trained on. And so, that makes it a very static technology. It takes a long while to train a model. It can be, hours or days or weeks even, to take a data set and produce a working model. So, there's all sorts of problems with that. So firstly, information changes quite rapidly in some fields. If you want to talk about, if I want an LLM to answer questions about what's happening in the stock market today,
Mm. Oh,
it's not going to be any use to use data that's like 4 weeks old. So, or football
I'd
games or what's in the
sympathize. Yeah.
news.
I'd sympathize with the LLM dealing with the stock data. It's like, hard to keep up.
Yeah.
But yeah, I agree with you.
So, and then there's a whole heap of information that's out there in structured data stores. So RAG is a technique that started to get adopted for how to get a lot of that information into an LLM. I guess we should say RAG stands for Retrieval Augmented Generation, which probably doesn't help understand it. But the idea is you can take data and it can become part of the body of knowledge that an LLM will use in answering the questions, and so it would go alongside the knowledge that the LLM has in answering the questions. And so, like for instance, one of the advantages there we were talking about the timeliness of information. So it's a lot quicker to update a database table with some new stock information than it is to retrain an LLM.
Mhm. That makes sense. And so what do you think is the state of RAG in 2024, or, in the maybe next year?
I think, yeah, it's a very interesting space. So, um, where to start really? There's a lot of development. So I guess RAG itself as a technique has been used for a good few years now. Um, I think most people who have been using RAG would be familiar with the idea that you take a document and unstructured data could be used in a RAG pipeline so that the unstructured data becomes part of the LLM's knowledge. And
Mhm.
so, the input to that is therefore a lot of documents. Um, very, very powerful technique. But I think some of the interesting developments are how we are starting to see, so graph RAG, so the idea of using knowledge stores as part of AI processing flows is a particularly powerful technique. And something else we can talk about today is agents. So agents are I guess we'll talk about that in a bit, but adding some autonomous processing units that work alongside the LLM. And I think particularly of interest at the moment, as people have been worried about the accuracy of AI and how
Mm-hmm.
the accuracy of the answers, bias. Can I rely on the information? Is it neutral or is it is it biased by information it's received? And
Right.
so the idea that you can add agents that also can form a critical part of the processing flow and
Mm-hmm.
can guide the LLM away from areas of bias. People are talking about explainable AI, so agents that help understand the logic behind a decision. So it's not just a bunch of text, but a bunch of text with reasoning and justification for why it's there.
Mm-hmm. That, yeah, that's lots of different topics. And yes, I'm going to ask you some more questions on that. But before I get to it, I want to ask this kind of controversial question: to rag or not to rag? I think there was a paper, then I have read a few articles, and then I have heard and got into conversations with people who were constantly debating whether to use rag or not to use rag. So I'd love to know your thoughts on that.
So, what does RAG do? RAG means that an AI processing flow will have up-to-date information.
Mm.
Um, it can have information that's tailored to you as a person. The difference between sort of asking a newspaper for its view on a topic versus asking your friend, I think you can start to see how RAG can be able to bring a lot of tailoring into
Yeah.
the knowledge that an LLM will produce for you.
Hmm.
I would absolutely be exploring in RAG in almost every problem space, I think.
Yeah, yeah, it makes sense. And plus, I think when it comes to computational expenses, it could be cheaper too. Do you think so?
Yeah, I do think so. So I guess the idea that you can put the right knowledge into an LLM, it's going to
Mm,
give you a more specific answer. You can see how that's. I mean, it's kind of complicated to explain why, but there's a lot more efficiency with that. If you get an inefficient answer, you probably have to ask more questions to get the answer you wanted anyway. So I think the idea that we can build processing flows that are much more specific to the questions that people ask and to their needs and to their situation and the information that's held available about them. It's going to make it's going to reduce computational cost.
fair, fair. And okay, so I know you mentioned GraphRag, and GraphRag, I know that vector databases are using GraphRag in it. So I have heard many use cases around this. Now, why and how does GraphRag come handy when you store your unstructured data in a vector database? I guess it also leads back to the knowledge graph. So it's just, yeah, trying to connect the
Yeah.
dots.
Do we want to try and I guess try to explain a little bit of the context of what a vector store does, just so we can
Yeah,
sort of like explain the journey.
let's do it.
So
Yep.
um, I don't know if people still go to libraries anymore, but there's a sort of an analogy with libraries, right?
Mm,
With vector store. So um, back in the old days, if you went to libraries, you would ask the librarian, I don't know, if I want to find out about dinosaur eggs, I would go in and say, where's the natural history? And they would say, yeah, it's on the top floor in the corner. And then, so you'd go and find the books around natural history, get a bit closer to the dinosaurs, and there, here's the bit where we talk about dinosaur eggs. You know, so librarians have this mechanism for making sure that books that are related to each other are close together. And
right.
so that's what, and so I guess, so
Mm,
we could sit down with perhaps a library floor plan and put an X on the spot and say, well, that's where
mm,
natural history is or where dinosaur stuff is.
yeah.
Um, and so stuff related, so I guess maybe the mammal books are close to the dinosaur books because it's also natural history,
Hmm.
but natural history is not near inorganic chemistry. And so, in our map of the library, you can see how the closer the crosses are where things are, more
Hmm.
closely they are related. And so there's this class of algorithms called embeddings, which we use in the world of AI, which
Hmm.
allow you to say that concepts are close to each other or related or they're not related. And so that's where we start on the journey. So we've got embeddings talk about how things are close to each other. Now, we actually, within a vector embeddings in the world of AI, it's quite complex. So we don't use two-dimensional crosses on a map. We're using like several hundred dimensions, and so it becomes impossible to visualize in your head. So we just leave the visualization behind.
Mhm.
But there's still the algorithms still perform this function of saying, I can tell you that these concepts are closely related or not related, or if I've got a concept, I can look near to the space around that concept and find related concepts.
Mhm.
So a vector store is a way of saying, starting off with like a point in a map, if you like, and saying what information have you got that which is similar to this in its concept.
It's, can I have a permission to take this example and use it wherever I can? It was
Yeah,
a
sure.
great
Yeah.
example. I mean, I think the first person I'm going to try and explain vector store is my dad, because he's been curious. He's not in technology, like not even close, but he is curious. And this example, it hit me. I'm like, huh, this could be easily explained to anybody, and they can understand the basic functionality of a vector store. So yeah, thank you for sharing that. It was really good to understand.
I mean, people start, don't they? You go and read the tutorial on how to use
Yeah.
a certain store, and it says, okay, to start with, you need a 768 dimension vector. Like, could we start somewhere easier?
Yeah, easier. Yes, exactly. What 768 dimensions? Fair.
Yeah. So I guess we were going down the journey of RAG.
Graph rag,
So
yeah.
I guess so our vector can be related to other vectors,
Right.
and it can be related to chunks of text. And so um, if when I go into the library, I'm looking for dinosaur egg books. The similar thing in a vector store is I say, can you show me information related to dinosaur eggs? It will
Mhm.
go and find a space in its huge vector embedding space, a
Mhm.
point there, and say, well, we've got some concepts related to that I've got some text I can show you. So here's some text that I took from, that talks about dinosaurs. Here's some text that talk about eggs. Here's something about dinosaur eggs. So it's very close to and you can start to use the closeness of the points to my vector to say this information is more relevant to answering your
Mhm.
question.
Mhm.
So, um, so where were we? So vector. So I guess it's something's called document RAG or unstructured RAG. Is the process
Yeah.
of saying, I have this concept. What blocks of text have you got for me? So then, if we go to graph RAG, the vector
Mhm.
algorithm says I can go from your concept of dinosaur eggs to some points in the graph that
Mm.
are
Okay.
related to your question. So
Question.
there might
Okay.
be in my knowledge graph a node that says dinosaur, and it's related to my original question.
Mhm. Okay. That makes sense. Okay. That's pretty
I
cool.
think we covered a lot of ground there. So
Yeah, we did. We covered vector store, we covered RAG, knowledge graphs, graph RAG, and how all comes together. That's perfect. And that actually gives me a nice segue to talk about Trust Graph. And I know your company, it uses open data formats and standards. Now, the question lies, how do you make money in this case?
well, that's a good question. And I think we're in a world of exploration here to find that out. But so for one thing, um, people want knowledge. Okay, so we can give people tools that help them. So I should explain what TrustGraph is to start with.
Yeah.
It
Mm-hmm.
is it's a platform which just brings good data engineering to some common AI algorithms. So we can make it very easy to start up a processing pipeline that does a certain job. And the one we've chosen to start with is GraphRag, which it is my favorite algorithm. So we've got a pipeline where you can take text and start to analyze it and build a knowledge graph automatically out of the text. So it's such a useful algorithm that we've released that in TrustGraph as an open source platform.
Okay.
But I guess the question about how to monetize that, I think
Yeah.
people are very interested in having knowledge, and it might be that not everybody has the compute power to take, a large body of text and turn that
Mm.
into knowledge. So one application is to produce what we're calling a knowledge core,
Mm-hmm.
which is a body. It would be basically a knowledge graph and all the vector embeddings, so that you've got you've got something that can just answer questions for you automatically.
Hmm. Okay. So when you started TrustGraph, what was your motivation? And to keep this, like I understand why you have the open data format and standards, but I'm curious, what was your motivation when you found TrustGraph?
Um, we I guess like a lot of developers, I spend quite a lot of time trying to solve AI problems by writing code in Python or bolting things together. And I think we had the feeling that, okay, well, why does it have to be like lots of Python code every time? Why can't I just like have these building blocks and plug things together?
Yeah.
And when you're solving everything from scratch, you end up solving some really common problems from scratch. So, okay, I'm loading data. What happens if the cloud service I'm using has a blip and something restarts? And I do have to start from scratch. No, I wanted to just replay the data. I wanted to
Mhm.
recover from the errors. So commonly, data engineers deal with things like data that gets slow, sometimes needs to be buffered. When errors happen, I want things to retry.
Mhm.
When things go wrong, I want the information that tells me how to respond to the error. Um,
Mhm.
if there's problems in my data, I want to know exactly what it is.
Mhm.
So TrustGraph has elements like these built into the platform. That's what we wanted to
Yeah.
start with, just good data engineering.
Nice, nice. That's a very interesting work that you guys are doing there. So now, so that was good explanation about, GraphRack and vector store and stuff. So I want to go into, before we wrap up our conversation, I'd love to talk about the topic that is very close to me, especially with the company that I work at, Explain. We are working on, building a nice agentic framework. So now I'd love to know, what are your thoughts on AI agents? Then second, agentic RAG. And do you see any use case or way to use knowledge graphs in an agent?
Yeah, absolutely. So, okay, let's dig into some of that. This is just a crazy big topic, isn't it? But
Yeah, yeah.
um, just to start the story, agents are little processing, I guess, autonomous units, aren't they, that sit
Hmm.
inside of an AI framework. And so
Yeah.
um, you could say, I want an agent to, like, if we're going to solve complex topics, it
Hmm.
might be the case that you can't just take a question and have an answer. So one of the things an agent might do is to take the question and start to plan and say, well, okay, in order to answer that question, we're going to have to invoke an LLM to do this and start to make a plan about the strategy for how to answer that question. And other agents might, um, do other things like, okay, well, I know that this system isn't able to answer that question, so I'm going to, I don't know, go and query Google and find out or
Hmm.
look stuff up. And so I think that's there's an area that's quite interesting here is if an agent is able to use a GraphRag algorithm to go into a body of text and start getting information out of a knowledge graph. I think you've got a very powerful processing pipeline there, the combination of agents, all sorts of lookups, and then knowledge graph,
Okay.
graph RAG algorithms to
Yeah.
really power the system with information.
And do you think that people are building such agents right now?
So we have some examples of that in
Mm.
TrustGraph actually, but I know
Okay.
people are doing that.
Okay.
Um, and there's other use cases I think, which is having agents to look at how problems are being solved within a processing pipeline and critique it and say, I don't think that answer's right, or this information over here should have been used to solve that. And so, adding explainability, adding some
Mm.
quality to the processing pipeline.
Interesting. And I know you mentioned something about explainable AI, and have you seen so many like interesting use cases where people have used, I guess, not just individually knowledge graphs, but like as we discussed, GraphRag, knowledge graphs, and all these different concepts. Have people been using like the combination of all these terms into explainability at all?
Um, I've seen demos. I'm not sure
Mm.
to what extent it's happening in sort of big production systems yet.
Okay.
Uh, I know that the concept showing up in papers. I guess there's the concept of LLM as a judge is one of the
Yeah.
terms that
Okay.
people are using for this. I don't know that it's happening in production scale yet.
Okay. And now new question comes to mind, especially when you said LLM as a judge. What are your thoughts on that?
I mean, I don't. I think we have to learn by trying, don't we? I think.
Yeah, I
Um,
bet.
can you, if people don't trust an LLM to produce an answer, would they trust an LLM to decide that the first LLM produced the wrong answer? I don't know. There's a lot to discover here.
Yeah.
I know some folks are very dubious about this, and um, but I think, the idea that, there's a lot of LLMs out there on the internet. So, using the power of all of those,
Mhm.
or multiple LLMs to improve the quality, to kind of cover the areas where some of the LLMs might have a blind spot is particularly sounds like a great technique.
I bet. Yeah. Yeah, you're right. Until we try it out, we won't know how it really works. Great. So, Mark, this has been an absolute treat. I'm pretty sure my audience are going to learn a great deal, especially the way you have described and broke down all the technical concepts into simplicity. I'm pretty sure that will be very helpful. So, thank you so much for sharing your knowledge, and also to all the listeners, thanks for tuning in. Until next time, keep exploring and stay curious. Thanks again, Mark.
Thanks. Bye.